Hi everyone, this is my presentation on my research project titled Integrating Audio and Text Data with Deep Learning to Detect Depression. Need for the research. Depression is a major depressive disorder that is affecting millions around the world. Early and accurate diagnosis is crucial for effective treatment. Traditional methods rely heavily on clinical assessment, self-reporting through questionnaires, which is subject to bias and like it is time consuming. The proposed approach uses like audio and transcript file like textual data to better classify the depressive classification using these two features, increasing complexity of real-world data. The data shared in real world contains like the text, audio, and video features, which contains cues related to the internal emotion of a particular person. By using these information, like a model can learn and like better assess the emotion that is undergone by a person. Rising application in mental health and AI. There is a constant demand for the applications in the health related field, and like using these model like audio, for processing audio and transcript file can better classify uh, the depressive nature of a person. Divergence in modality characteristics. The characteristics of the audio and the textual file is basically different, like where like the audio is continuous and temporal, like whereas like the text file is like discrete and sequential. So combining these two modalities can help better assess the depressive nature of a person. The research question is like how effectively can a GRU LSTM model for transcript data can be combined with a hypertuned like a CNN model for audio data using a meta-learning approach to classify depression severity. The dataset is downloaded from this particular URL. Like this dataset name is like the distress analysis interview corpus. It contains like a clinical interviews to support the diagnosis of psychological distress conditions such as like anxiety, depression, and post-traumatic stress disorder. To gain access to this dataset, like you can use this URL to submit an end-user license agreement and like to download the dataset. The dataset contains like video recordings, audio files, and like the questionnaire responses in the CSV format. Dataset description. So the dataset contains like 189 zip file folders, like with the session IDs starting from 300 to 492. And like the screenshot shows like the first column shows like the list of participant ID present in the dataset, and the PHQ-8 binary score, which is like the depressed and the non-depressed class, where like 0 stands for the non-depressed and 1 is like the depressed class. So it is a binary classification. For the development of this research, like for training and testing the model, like I've used this particular file, which is available as part of the dataset. Overall, the dataset contains 189 folders, out of which like these two files contains like 142 records. So which like 35 is for like the development and like the rest is for like the training the model. Exploratory data analysis. So the histogram contains the distribution of the PHQ-8 scores of all the participants in the dataset that are taken for the research. Any score that is above 10, like it is like having a depressed that comes under depressed class, and like scores below 10, it's categorized like the PHQ-8 binary as 0, which is like a non-depressed class. The bar plot shows like out of the records taken for this research project, 70% of the data set is non-depressed class and like 30% is under the depressed class. And the spectrogram represents like the MEL frequency spectrogram, which is like the visual representation of the audio wave signal. So in this for this particular research project, the methodology that I have used is like to extract features from the text data, like making pre-processing by data cleaning, and like uses a glove embedding and like converting it to token and like use it in the deep learning model for a text-based classification, and using the audio features to remove the noise and like extract features like MEL frequency septal coefficient, the chroma features, and the MEL frequency spectrogram coefficients, and use these particular parameters to train the model using a audio-based deep learning model. Here in this case, like I've used like the hyperparameter tuned CNN model and like use a fully connection like using a meta learner to make a binary classification. The data preprocessing steps in like the text data include like the removing of punctuations, like ignoring the cases, and like removing the abbreviated words, and like removing the most frequently and the sparingly used words in the data from the particular data set, and trained using the global vector. That is a repository, like that's a dataset, pre-trained dataset having to create an embedded matrix. So this is converted to a token and to use it in the proposed GRU and or in the LSTM model. Similarly, from the audio features, like the noise is removed from the audio file, so that like only the conversation between the participant and the speaker is being captured, and that the features are extracted only from those particular file. So to evaluate this particular functionality of this model, precision, recall, and F1 score are used to evaluate. So the design and implementation of these three deep learning model. So like in the GRU and in the LSTM model for the transcript data, like I have used the 5-fold cross validation to train the model with the limited data set. And like I've used SMOT to balance the classes, like due to the imbalance within the depressed and the non-depressed class. And I used like the Adam optimizer to compile the model. So I have used like the 3 bidirectional GRU and the LSTM model, like in a separate deep learning model with a 40% dropout rate with a sigmoid activation function with an epoch of 20. Similarly, like for the audio file, like the three layers for 3 features for the CNN branch, right? I used the one-dimensional filter, which has like a hyperparameter tuning to tune the filter, the dense units, the dropout rate, and the learning rate. Finally, like these two features are combined using a meta learner. Where here in this case, like I've used the gradient boosting classifier with a tree size of 100 and a depth of 3 at a learning rate of 0.1. So here's the evaluation part of the proposed models. Like the bidirectional GRU model, the model has classified with an accuracy of 0.60 with a precision of 0.40 and a recall of 0.33 for the depressed class. From the confusion matrix, like the model has correctly classified like 17 non-depressed and 4 depressed classes accurately. From the LSTM model, like the model has an accuracy of 0.66 with a 0.50 precision and 0.33 for the depressed class. And like the model has classified 19 non-depressed and 4 depressed class correctly. So looking at these two model, like the LSTM performed slightly better. So like we will be using this LSTM model for the further prediction. So this is the hyperparameter tuned CNN model, like for classifying the audio feature, the depressed nature from the audio file. Here, like the model has evaluated like 19 non-depressed and 5 depressed classes correctly with a precision of 0.56 and like the sensitivity of 0.42 for the depressed class. So here in this meta learner classifier, so I have used like the hyperparameter tuned CNN model and the bidirectional LSTM model to make a final prediction. So it came like the model can able to classify with an accuracy of like 0.94 with the precision of 0.86 here. So the model has classified like 21 non-depressed and 12 depressed classes correctly using the features from the audio and the transcript data. So to conclude this particular research, this research demonstrated the potential of using like the audio and the transcript file to automatically detect the depression classification. This approach of meta learner, right, like to show the highest performance, indicating like the combining the modalities can help combine the participant responses with virtual interview prompts. So like this helps in better classifying than the unimodal approach. Thus the future work focuses on like enhancing more model robustness and generalizability, and like the developing real-time depression monitoring tools where like some real-world applications can be used based on the models that have been trained using the dataset, and integrate the model with cross-language and cross-cultural context. So like using different data sets like with emotions and like context from different regions of people around the world, like so like, you can train this particular model with different context to see like whether how effectively like the design model helps in classifying the depression. Thank you.